Hi, and welcome to the third part of my implementation of CS50 Finance. Today, I'm going to show you how you can create the buy page. As you can see, it is a bit more sophisticated than the previous ones, but it is not something you should be afraid of. The key thing here is that you should create a new table in order to store new information. I'm going to show you how you can go through all of the pages and extract the information you're going to store into your new table. First, let's take a look at the example solution of CS50 stuff, which is this one. There are two tables in this app. The first one is displayed into the index page, and as you can see, there is the symbol, the name, the shares, the price, and the total price for each product. The other one is the history page, and the table here is slightly different. It contains the symbol, the shares, and the price again, and the date and time the transaction was made. Of course, we could extract the information from here, but imagine that you didn't have this example solution, because in most cases you won't. I want to show you how you can do that based on the information you have in the documentation. Let's first take a look at a table that we already have, which is the table users. For each user, we store a unique ID, which is the primary key, the username, the hash, and the cache of the user. We'll want to create a new table, which is called transactions. And here, we are going to store all the information that should be displayed into the two tables on the index and history page. But first, let's think about how we can actually relate the two tables, because that's the main purpose. We should have a foreign key in the second one that relates to something in the users table. So the easiest relation we could do here is by connecting the user ID in transactions, which we are going to create, with the ID in users. Now maybe you wonder why. Well, because the user ID is always very easy to obtain. We can always set up a new variable, which is going to be user ID equals session of user ID. So whenever you wonder what your relation should be when you have two tables, think about what is the easiest information to obtain. Because imagine you try to link the hashes. How can you obtain the hash? It would be harder, right? Plus, we know that the ID in user is our primary key, so we would probably want to relate it to something else in the other table. Alright, so let's start actually creating and storing the information into our new table. The first thing we would like to have is the ID, which is going to be unique for each transaction, and then, like I said, we want our user ID, which is going to be our foreign key, user ID. So this user ID is going to be the same as the ID here in our users table. And whenever we have the ID from users, we can obtain all this information from this table. Now let's take a look at index and history and see what information we need to store. I have highlighted some things for you just to make it easier to understand. So the first thing we would like to store is the information about which stocks the user owns. So this is basically the name of the stock, right? Let's write name here. Then we have the number of shares owned, so shares. After that, the price of each stock, price. Then the total value of each holding, which is equal to the shares times the price. So obviously we don't have to store that separately because we already have the singular price and we have the total amount of shares, so we can just multiply them to obtain the total value. The next one is the cash balance. And now here's where relational databases get powerful. Since we have two tables that are related, we can easily go here to users and look at a cache. And the other thing we are required to use is grand total, which we already have. Alright, let's now take a look at the history part. For each row, make clear whether stock was bought or sold. So we want to either write bought or sold. Well, I'm going to call this type, so the key is going to be type. Then we need the stock symbol, the price, which we already have, the shares, which we already have, and date and time. So let's enter a new key here, which is, I'm just going to call it time. And this was actually the last key we want to store in our new table. So that's the way you can process. So let's now open our finance.db file and create our new table. SQL, and now we can start writing. So how can we create table? Well, obviously with create table, and the name is going to be transactions. Of course, you can name it something else, it doesn't matter. The only important thing is to be descriptive. Let's open the bracket. So the first thing we would like to have is the ID, which is going to be an integer. It is our primary key. And we want it to auto increment, right? Because we don't want to do that manually. So auto increment. Then we have our user ID, which is going to be integer again. Not now, just in case something's wrong. We don't want an empty user ID. Then we should have name, which is going to be text, not now. Shares, integer, not now. Then the price. Now notice that the price is not always going to be an integer. Therefore, you don't want to use integer not now, but instead numeric not now. Oops, down here, numeric not now. Numeric is just more general. It is both going to accept integers and floats. I accidentally hit tab. All right, after the price, we have the type of our transaction, which is going to be text not now again. Then the symbol, text not now. And the last thing is going to be our time. Now, instead of obtaining the time from Python, we could just use a timestamp here in order to obtain the current date and time. So what we should do is timestamp default current timestamp. So by default, it is going to obtain a current date and time and store it as a value of our time key. And the last thing is to actually reference the foreign key. So let's do foreign key. And now in brackets, we want to write user ID because this is our foreign key. Then references. And then what does it reference? Well, it references user's ID. Now we can close our bracket, put a semicolon, and hit go. So, seems like everything's fine. If we go to structure, we can now see two tables. The second one is transactions. And if we open it and go to structure, we can now see all of our fields, the types, etc. Once we have our table, we can actually start writing code. I'm going to leave this file open because we may need it further on. Let's now go here, remove this, and start solving our problem. The first thing we're going to do is the same as what we did the previous two times. We want to check if our method is get or post. If it's get, then we want to render the by template. If it's post, it means that we have already filled in the form and we have sent it. So if request method equals post, I'm going to do path for now because the get method is always easier. Usually you have to render a template. So else, we want to return render template, and in brackets we put the name of our template, which is going to be by HTML. So now let's go here into templates and actually create our by file. So new file, by HTML. Now again, I'm going to copy probably the login template because you already know how to write it yourself. I'm going to replace login with by. You're going to send it to by. So let's take a look at the fields that we're going to need. So we need a text field whose name is symbol, and then a text field whose name is shares. All right. Let's go here. So the name is going to be symbol. The placeholder, probably symbol again. And the next one is going to be shares. The placeholder, shares again. And the type should be text. Okay. Let me just replace this text with by, and we can actually try to see if this works. So let's go here, login, hit by, and yeah, we have our template rendered. Now let's close login because we don't need it anymore. And I don't think we'll actually need the by template anymore, so I'm going to close it as well. And now let's go here and work on our post method. The first thing we would like to do is obtain the value of the symbol and the shares field. Symbol equals request form get, and now we write the name of the field. So since I shouldn't have closed this, since the name here is symbol, you should write the same name here in our application pie. Something you could do here is convert it into uppercase, because as you can see here, all the symbols are in uppercase as well as in the history page. You can do it later on, but I'm just going to set it up here in order not to forget it later. Let's go back here and read the next thing we should do. Render an apology if the user is blank or the symbol does not exist. Alright, let's go here, and first let's try to obtain the item. Now how can we obtain the item? By using our lookup function. So lookup symbol. Recall that the lookup function is into our helper spy file, which is here. And whenever we enter symbol, it is going to check if it is valid, and if it is, we are going to obtain the information about the particular item, the name, the price, and the symbol itself. So first, let's check if our symbol is empty. If not symbol, it means that the input is empty, it's blank. Then we would like to return apology. Please enter a symbol. Else if not item, want to return an apology, invalid symbol. Now, why am I writing else if not item? Because if our symbol is invalid, the whole lookup function is going to return none, and therefore this is going to be evaluated into true, and we're going to return our apology. Now let's get to the next step, which is the shares field. Render an apology if the input is not a positive integer. So let's first check if it is an integer. Now there are multiple ways to approach this problem, but one of them is to use a try except statement, and I feel like I haven't showed it much. I think I have only showed it once, so let's do that again. Try shares equals integer of request form get shares. Except, I'm going to explain it in a bit, don't worry. And we want to return an apology. Let's say shares must be an integer. Alright, so let me explain what you are doing here. We are taking the shares, we are taking the value of this field here by request form, get the value of shares. And we are trying to convert it into an integer. But if we cannot do that, we are going to go here into except because we have run into an exception and we are going to return an apology. So it is actually similar to the if-else statements. So if we can convert it into integer, then set up this variable. If we can't, we want to go here and return our apology. And something else we should think of is we should check if this integer is actually positive. So we're going to use an if statement here. If shares is less than or equal to 0, then we want to return an apology again and say shares must be a positive integer. Alright, so it's important to explain that it doesn't really matter what order you put those statements in, but the fundamental thing is to consider each of those cases. Each of them is written here, so you should read carefully and implement all of them, because otherwise you may not get a perfect score on check 50. So the next step is to start obtaining information about both the user and the transaction he's going to make. Let's first obtain the user's ID. User ID equals session of user ID. So what we're doing here is we are going to our session and we're checking the value of the key, which is user ID. Then we can obtain the cache of the user by going into our users table, because remember that in the structure of users we have the cache. So let's set up a new variable, cache equals, now db execute. I hope you know what this means. And we want to select the cache from users where the ID equals, and now I'm going to use a question mark to prevent from SQL injections. And here, after closing my quotes, I want to pass in my user ID. So what we're doing here is we are going to users and we're looking for the cache of the user with this ID. For instance, if the ID is 3, we're going to look at a cache of user 3. There is one very specific thing to take into consideration here. This command is always going to return a list of dictionaries. In this case, a list with one dictionary. I'm going to demonstrate that now. So let me set up a print statement, print, and I'm going to actually use a formatted string in order to put some empty lines. Then I want the cache and some empty lines again. So let's put one return statement here in order to make it work. And return redirect to the home page. Now, we haven't implemented it yet, but in order to make this function work, we have to return something. And that's what we're going to ultimately do, right? So now let me log in. Go to buy, hit Apple, for instance, 4 shares of it. And now this is normal because we haven't implemented our index page, but let's go here. That's what is important. We have a list of a dictionary and we actually only care about this value here, right? So how can we remove the square brackets and the curly braces and the cache key and only obtain the value? Well, the easiest way and the most straightforward one is to open square brackets and use an index of 0. So basically we're saying go to this list and return, oops, let me go back, and return the first element. In this case, the first element is this whole dictionary. And to get the value of cache in this dictionary, we can use the square bracket syntax again and put the cache, the key, in here. Now this is going to return only 10,000 or whatever the sum is. Alright, we now have the cache and we want to obtain some more information. For instance, we will need the name and the price of our item. So we can do item name equals item square brackets name. Now recall that we obtained our item here and the lookup function always returns a dictionary with 3 properties and one of them is name. So we go here and tell the interpreter return the value of our name key. Then we want to do the same for the price, so item price equals item square brackets price. And And we would probably like to have our total price, the total price of the product. So let's call total price equals item price. So this is basically the price for one share multiplied by the count, the number of the shares, like this. Let's go back here and read what else we have to do. So render an apology without completing a purchase if the user cannot afford the number of shares at the current price. So we want to check if the cash is less than the total price. If it is, we want to return an apology, so return apology. Let's say not enough cash, for instance. Alright, else, if we do have enough cash, we would like to do two things. First, update the user's table and subtract from the cash of the user the current price that he has paid. And second, insert into our transactions table, the one that we created a bit ago, the information about current transaction. For instance, the name of the product, the price, the shares, etc. So let's first update our first table. So db execute. Update users, this is the name of the table. Set the cash equal, and I'm going to use a question mark again to prevent from injection attacks, where the ID equals question mark. And now for the first question mark, I want to use the cash, the value of my cash variable. So with a comma, I can enter cash, but in this case, cash is not enough because this is going to return the previous amount of our cash. But since we have already bought something, we want to do cash minus total price. So if he started with $10,000, which is going to be the value of cash, he has bought items for, say, $2,000, and now we want to update his cash to $8,000 because we have subtracted $2,000 from the first sum. And then enter the user ID. User ID. So what we're doing here is we are going to users, we're finding the user. Let's talk about number 3 again with ID of 3, and we're updating his cash because he has bought something and obviously he has less money now. Then we would like to insert the information into our transactions table. So insert into transactions. Now here we want to enter all the keys. So we have a user ID. Now remember that the ID is auto incrementing, so we don't have to care about it now. User ID, then the name of the product, the shares, the price, type, symbol, and notice that I'm not going to enter time here because I've already taken care of it when I created my table. The last thing is going to be the symbol, and let's write values. And here, I had to use values, and here I'm just going to use question marks again for security purposes. There are 6 of them, so 2, 3, 4, 5, 6. And after this, on a new line, I'm going to enter the actual values. So the first we have our user ID, which is up here. So user ID, then the name of the item, so item name, the shares, which are just shares, we have obtained the value up here, int of request form get shares, then the item price, which is here, the type. Now the type is always going to be by, since we are inside of the by function. So by, we can just hard code it, and then the symbol which we have obtained up here. Now we can go here. Let me actually create a new registration just to be sure that everything's fine because I haven't used it in a long time. Let's say just E or something like that. Okay, it works. And now let's go to buy, choose Apple, 4 shares, hit enter. Everything's fine here. As you can see, this is our index page which isn't created yet, but if I go to Finance DB, In Open Users, we can see our user who has cash of 9,469.48. If we go to transactions, we can see the price, which is 132.54, the type, which is by the symbol, and the time, most importantly, which has been entered here by our timestamp. Of course, we have the name, the user ID, and the ID. So this was everything for today's tutorial. I hope it has been helpful. If you have any questions, of course, you can ask me in the comments or on any other social media. Bye for now, and next time we're going to work on our index page.